In stats, we started talking about standard deviation. So this is the distance on average the values are from the mean. In AP stats, we are going to be using SX by dividing by n minus 1. This right here is called variance. Notice it hasn't been square rooted. So that is the formula for sample variance. And at the bottom, right below that, is the formula they give you on your formula chart. That is your sample standard deviation. So when we write that, we just write S. And when we write sample variance, we write S squared. They may ask about sample variance in a question, and just know that if you're doing 1 var stats on your calculator, you need to square S, and you get it. Because typically you're just going to use 1 var stats or some function on your calculator to get standard deviation. The big difference between this class, AP Stats, and for example IB or some other statistics classes is some others like to use population standard deviation or population variance. So if you divide by n, that is lowercase sigma squared, which is the summation, it looks very similar by the way, of the deviation squared divided by n. And the population, so let's write population variance and if you square root that number, you get the population standard deviation. So I will say it is important to be aware of the notation, sigma. The sigma thing gets confusing because technically we have 2 sigmas that I've written or typed on the page. This right here, let me change colors. This is a lowercase sigma, and this summation is a capital sigma in the Greek language. So it is important to realize that sigma, this right here, is the population standard deviation. That could come up, but in terms of value and what you're going to use on your calculator, you'll always use S. All right? So let's look at what this formula is. They take each x value, so here's the first x value right here. They subtract the mean from it, and that all by itself is a deviation. If you're looking at the sum of just the deviations from the mean, you're going to get 0, which does you no good. So they square them so that you have value. Now that makes a gigantic number, which is why they square root it to undo that squaring. All right? So it is kind of important to know the details of the formula, but to be honest, we'll typically always use 1 var stats and get standard deviation. You won't have to do it by hand. So if you are curious, you know, we had this Barry Bonds problem right here. And when I did 1 var stats earlier, I wrote down the mean. And the mean was 36.0476. I happened to write down the standard deviation as well. On your calculator, on the output for 1 var stats, it puts a little X next to it, and it gave us 12.6865. Now that is very tedious to do by hand. The mean is easy. you add them all up and you divide by 21. So let's look at the calculator for a second. If you go to the calculator and you type in all your numbers, we could derive this by hand. So you come up here and we want to go each x value minus the mean. So I named all my x's A, as you see at the top right here. So I'm going to go A minus the mean, 36.0476. A is a variable, and these are all deviations here. All I'm doing is proving that one var stats is right. You don't have to do this. So those are deviations, just subtracting the mean. I want to square all those deviations. So I'm going to take this list of deviations and square them. So b squared. Now I have the squared deviations. So if you go back to the formula, this right here is a squared deviation. The formula tells us we need to add them all up. So I need to add up all the squared deviations. I go back to the calculator and I name my list right here, and I'm going to do one var stats for that list because I don't feel like adding all 21 of these. I'm not going to take the time to do that. But remember, one var stats does the sum of your x's. So let's see. Stats, one var stats. I have one list. I named it C. Those are the squared deviations. And I get 3218.95 when I add up all of these numbers here. All right, so that's the numerator of the variance. This right here, 3218, is the numerator. It's this value right here for the Berry-Bonds problem. I'll write it. All right, so now all I have left to do is divide by n minus 1. So I just go to a blank calculator. I have 3218 point, I'm trying to be as precise as possible so we can get the same output that the calculator gave us in one var stats. I'm dividing by 21 minus 1, so really I'm dividing by 20. And that right there is our variance, 160.948. That's s squared. So if I square root it, I get my sample standard deviation. 1268.65, which is what I wrote down just a second ago. 1268.65. Pretty cool. And that's all the calculator does. Now, you guys watched all those steps with the spreadsheet. That's letting the calculator do a lot of math. In the old days, they used to do this by hand. That is no fun. I'll admit, I used to have to do it by hand. So be grateful. We are now using the calculator and one var stats to get this number. This number right here, 1268.65, is the standard deviation. So at the very end of your notes, or on that page, let's wrap this up. Find the standard deviation for the home run king problem. That is 12.6865 home runs. It does have units, whatever you were counting or measuring. So we want to say on average, Berry-Bonds each season were 12.6865 from the mean. Notice there's a few concepts up there right above this, characteristics. I already talked about SX, I believe. It's how far on average values are from the mean. It has to be positive, because remember, you find the deviation and then you square. So it has to be either 0 or greater than 0. If every value is identical, then it'll be 0. It has the same units as whatever it is you're measuring, which is why I said home runs right here. And like the mean, it can be affected by outliers. So those are important things to remember. Last little thing in this handout, you have a few concepts about what outliers do. I keep going by this page right here. That's another problem. We'll do that down the road. So we want to be aware of how outliers affect things, and I would say yes, they do affect the mean. No, not the median. This is just a middle value. We do not care about the extremes of a data set for the median. The range, yeah, because it is the max minus min. So if you have a huge number or a tiny, tiny number, that is greatly going to affect the range. I would say it's directly affected by the outliers, potential outliers. We're going to say no for IQR, because that is just Q3 minus Q1. We're not talking about the extremes. We're talking about the first quartile minus the third quartile. And this, just like the mean, yes, because all values and deviations are used to find S. All right, that's the end. I'll see y'all later.